Hi, this is Mike Lopez, and in this video we're going to be looking at arithmetic and geometric series. Okay, let's make a start first of all with arithmetic series. Okay, let's change colour. Let's go for a starting number. How's about 2? And what we need to do on an arithmetic series is to keep adding consistently another number, or possibly even that same number, but think of any number and continue to add that number to find a new number. So in this case we start with 2. Why don't we add 3 to that? We get 5. Add 3 again, we get 8. Add 3 again, we get 11. 3 again, we get 14. 3 again, we get 17. So yeah, you get the idea. So you keep on adding 3 all the time. So you'd expect 20 to be after the 17. Okay, so let's start at 2. That's what this arithmetic series says. It's going to start at 2. Therefore, we can say A is 2. So A is our starting number, if you like, which is quite standard. What is the common difference? What's this common difference that we're adding to one value to get the next value? Well, in this particular case, we chose the common difference, and we'll underline the D for difference there. So our D is chosen. We obviously realized that D was 3. Okay. And yeah, we just add in here, it's added to the previous entry to get the next entry, of course. Okay, let's have a look at some formulae involved in arithmetic series. And the first one I'd like to look at is a formula to find the nth term. Okay, so if you're thinking of the third term, n would be 3. If you're thinking of the sixth term, n would be 6. Get the idea? So in general, it's the nth term. Right, so how do we go about finding this? Well, the nth term is A plus n minus 1 lots of D. That's the formula you use, and you just plug in your values with any given arithmetic series. So let's have a look at an example. The 7th term. Okay, 1, 2, 3, 4, 5, 6. You've got 6 given. The 7th term, we just use that formula. A, we know, is 2. We put the minus 1 in the brackets there. We know that n is 7. So 7 minus 1 goes there. That whole bracketed term multiplies D, and of course, we know that D is 3. Okay, and so we're going to simplify that lot out. 7 minus 1 gives you 6. 6 times 3 gives you 18. 2 plus 18 gives you 20. Okay, so the 20 is the 7th term, so it comes after the 17. So indeed it will go in there, and yeah, looks right. So we're quite happy with that. What about the sum of so many terms? Okay, so the sum of n terms. And we can write that as Sn, or S subscript little n, and the formula is n over 2 lots of all this lot 2a plus n minus 1 lots of d. Okay, here's a closing bracket there. Okay, let's have a look at an example use for that one. How about the sum of the first 4 terms? S4. Okay, so we're going to write S subscript 4 is equal to, and we just use the formula. Okay, so we get n over 2, n here is 4 over 2 lots of, 2 lots of a. Well, in this case, we know that a is 2 plus n minus 1, 4 minus 1 lots of d, and d has a value of, 3. So we put a 3 in there, close that bracket, so that bracket there matches that opening bracket there. Okay, and then we're looking to simplify that lot out, so therefore the sum of the first 4 terms is going to be 4 over 2 gives you the 2, 2 2's are 4, so 2 lots of 4 plus 4 minus 1 gives you 3, 3 3's are 9. Okay, so that's 2 lots of 13, which of course is 26. Okay, so what we're saying is the sum of the first 4 terms in this arithmetic series is 26. So there's those 4 terms, add them up, 2 and 5 7, 7 and 8 is 15, 15 and 11 26. Good, so we have that one right. Excellent. Now let's see if we can move on and consider some geometric series. Geometric series. Okay. Why don't we start by writing down a typical geometric series? How about this one? 2, and what I now need to do is to think, well, what is a geometric series? Well, as it says in your workbook, you have to multiply by a particular term consistently. So we're going to multiply everything by 3. So 2 by 3 gives the 6, 6 by 3 gives 18, by 3 gives 54, by 3 gives 162, etc, etc, etc. You could carry on after 162, and of course you would get, you guessed right, 486. Okay, so let's have a look and notice some things about this particular geometric series. It starts at 2. Therefore, we can say A equals 2. Nice and easy. Another thing we can notice is that there is a common ratio. Okay, so there's no difference here. The difference belongs to the arithmetic series. So there's a common ratio, and it's 3 because that was the number we were multiplying by each time to get the next term. So r equals 3. So let's just emphasize here, new term is 3 times previous term. Okay. Let's see if we can look at some formulae then for geometric series. And the first one we'll look at predictably is what is the nth term. Okay, so we need a formula for the nth term. And again, it's given in your workbook. We'll reproduce it here. AR to the n minus 1. Okay, let's do an example use of that. That's the series we're interested in. Let's concentrate on possibly finding the fourth term. Find the fourth term. Okay, and we know, of course, there it is sitting there, it's 54. But we could be asked to find the 97th term or the 1,356,000th term. And then you wouldn't sit there and keep on multiplying by 3 each time, you'd be there forever. So that's why you need a formula to help you to ascertain all of these values. Okay, so the objective here then is to find that fourth term. So we can start writing then the fourth term equals, and we're just using the formula AR to the n minus 1. A is the first term, which we know is 2. R is our common ratio, which we know to be 3. And we can find out what the common ratio is. If you're just given the series like this, then you work out the common ratio by get one term divided by the previous term. So we could pick 18 and divide it by the previous term, which is 6, and you end up with R equals 3. And you could do the same with 162 over 54. So we're going to put 3 in there, and that is raised, as it says in red there above, to the power n minus 1, which is 4 minus 1. So 2 lots of 3 to the 3. Yep. Which is 2 lots of 27. Yep. 3 by 3 by 3 is 27. And 2 27s is, of course, 54. So what we're saying is our formula is correct because the formula says the fourth term should be 54, and indeed we see that it is. So we're very happy with that. Excellent. Okay. Now, the last thing I'd like to do is to find the sum of n terms. Okay, so we can write that as S as n, as we did previously. And the formula, as you see in your workbook, is A lots of 1 minus R to the n over 1 minus R. Okay, I'll scroll down a bit, and now we're looking possibly, let's do an example, we can see this more clearly. Let's see if we can find the sum of the first 4 terms. Okay, written like this. S4 equals, again there's the formula there in red, and we just plug in our values. So we know the value of A. Okay, so we're going to put that value in. A was the starting value, which was 2 lots of 1 minus R to the n. Well, you know what R is here. In this example, you've chosen R to be 4. Sorry, you've chosen n to be 4. So 1 minus 3 to the 4. Okay. Over 1 minus R, so 1 minus 3. Okay, and this thing simplifies to 2 lots of 1 minus 3 to the 4. So 3 by 3 by 3 by 3, which sounds a bit like 81. Okay, that's good. And that all sits over 1 minus 3, of course, is minus 2. Okay, so we're almost there on this. So what we can say is S4, or the sum of the first 4 terms, is 2 lots of, well, 1 minus 81 sounds like minus 80, and that all sits over minus 2. Okay, some cancellations. The minuses cancel, the 2's cancel, and we're proposing the sum of the first 4 terms is 80. So let's go back and have a look upstairs. The sum of the first 4 terms, so this lot here, so you're going to add them up. That's 2 plus 6 gives us 8. 8 onto 18 gives you 26. 26 at 54 does indeed give you 80. So we're happy with that. Okay, see you in the next video.